Welcome back to Databytez, your source for data-driven principles. Today we are taking a trip down the technical side of data once again in discussing data types. So in a previous video we discussed levels of measurement, and I kind of put it as why 1 does not equal 1 some of the time. And now data types is kind of the how things are, so how 1 isn't equal to 1 all the time. And so it's the way technology kind of sorts things, and it's related to data structures in certain ways. We're going to look at certain things like int, float, decimals, kind of that stuff like that, and how computers or technology kind of deal with it. So you remember that was called the primitive data structures, and so we're kind of looking at that. And this video is kind of divided into two parts. And the first part, we're looking at data types from a general programming perspective. In this case, Python, we're looking at that way. But we're going to see in part 2 how that parallels to more commonly used technology in the office, namely Excel. And you're going to see how much in common Excel has with a programming language like Python in this regard, and with a lot of programming languages, because again, I always try to harp on this, is that Excel is actually a programming language. It's not just these aren't formulas that you're writing, they are functions. And Excel is definitely a functional language. But enough of that, let us start diving in here. So I have my IDE open, and as always I'm importing NumPy and Pandas because we're going to be using them in our discussion here. So let's start by running that. And so here I have x1 equals 1 and x2 equals 1 as well, except I added a 0.0. All right. So when I make these variables exist and I say, does x1 equal x2, I get true. However, if I ask, does x1's type equal x2's type, I get false. Now you might be wondering a little bit, why is that? Well, if your suspicion is that it's leaning towards that 0.0, you are right. So if we were to see what the type of x1 is, we can see it's class int, but type 2 is class float. And you're like, what is a float? Well, a float is basically the computer way of saying, the technical way of saying just a fractional, a decimal number. And we can still manipulate 1 even further. So if I put this little str over here, I have 1 as well. And then if I ask, does x1 equal x3? I get false. Do x2 equals x3? I also get false. So it equals to none of these things, and that is because x3 is a type string. So I've introduced 3 things here: an int, a float, and a string. And I kind of define them here, and as well as introduce another one known as a bool. These are your kind of data types. So an int is your standard whole number. And it's important to know how your technology deals with the conversion to int, and we'll get into a little bit more of that in a bit. Float, this is the decimal or fractional number. The number of values past the decimal point is known as the precision of a float. And a string, this is your text values. And bool or boolean, this is your true-false binary. True also corresponds to 1, and false corresponds to 0. So you're able to do a little bit of algebra with this, and this helps you evaluate whether things are true or false. But these are kind of the 4 big data types. There are more. There are things like complex and stuff like that, but really, if you know these 4, you'll be fine. And so let's look at the behavior of int in changing a float to an int. So we're going to have x4 here equal 1.99. And just before I convert it, or I change it into an int, what do you think it will be? Take a quick guess on what you think the value will be. So I'm going to print the int version of x4, and it ends up being 1. You can see it down over here in the console. We went down to 1 instead of 2. So the behavior of converting floats into int in Python is to just drop whatever is behind the decimal and just keep the whole number. Now this isn't always the case. As we'll see in Excel, it does not follow this logic. Instead it rounds up. But just being aware of that can be important depending on the particulars of what you're doing. And moving down to bools, here I have true, and I'm going to say true equals 1. So we can see the behavior of the Boolean type. And we can see this is true. And if I say false is equal to 0, also true. Now, although we have 4 main types, sometimes the implementation of these types are a little bit different. Now, this kind of goes into, I would say, a bit of efficiency. Some things are a bit more efficient. So on the technical side, NumPy is very fast relative to just base Python because NumPy is actually written in C. C is a very low-level language that is very fast, a lot harder to write in than Python, but you're able to leverage the power of C by having this library of it at your fingertips. And so if I'm able to say x5 is equal to NumPy int 64, and I were to say does x1 equal x5, I'm going to get true, NP true, in fact. And if I get, is the type similar? Actually, I don't know why I wrote it this way, but it was actually supposed to be this way. Let's write this out. I get false, so they are not the same type. So just because it says int, and you might think, oh, it's the same thing, it is not actually the same type. And sometimes that can have implications depending on what you're trying to do. So it's really important to understand your data types and what you are working with. And then finally we go down here to the inference. So different technologies like to infer things. So if I go here, I have a nice little CSV. Oh, that's right here. This little inferred CSV. So let me open that. Where are you? So here I have a little CSV. And if you remember from our discussion on levels of measurement, this is a categorical or nominal type of data because it's dictating the class. Now we don't know if there's any order to this, but we know we have 3 classes. We have dim1, which has a whole number, a decimal, and another whole number. Dim2, which is 2 whole numbers and some text here, hello. And then dim3, which is all 3 whole numbers. Now, something important to note, this is a CSV. CSVs are flat files. There's no metadata containing here to what things should be. And so different technologies try to guess what the appropriate type, data type it is for a particular column. And we're going to see that. And it kind of makes different guesses here. So NumPy, I have here load text, the inferred CSV. Should dictate it's a delimited text because CSV stands for comma separated values, so they're delimited by commas. And I'm putting here data type string, and there's a reason for that. So let me first get this to appear. And so the data type of this is U8. And that actually stands for Unicode 8. So we have a new type introduced. It's not just the string. Now we have Unicode. Now this is not something you'll probably encounter very often unless you're really working on programming. You're not really going to need to know Unicode. I didn't know what Unicode was really until I started looking into programming languages. But it's kind of just a way of assorting text. So you have Unicode, which is probably the biggest one, and then you had ASIC, I think that's what you call it, and there's some other ones too, and it's just an evolution of how we've gotten computers to recognize text and the number of symbols that are recognized. But that is how I made it work with NumPy. And if we look here, we remember we're able to visualize this or view it as an array. Everything here is in a string, NP string. And class looks a little funny. The headers are not really, what's the word I'm looking for? Graduated into being the column headers here. They're just another row. And if I do not dictate, if I let NumPy to try to handle this without enforcing the data type, we're going to have a problem. So we cannot convert string. It does not know. So if you didn't know what a string meant, you might be a little bit confused here. And also just not understanding that, NumPy is numerical Python. It is a number crunching tool. So it does not want to handle string. On the other hand, Pandas, which is built on top of NumPy, along with some other things with it, is actually meant to deal with it. So if we load this in, we get to see how Pandas deals with the problem. So here you can see the highlighted values indicate, or things with color indicate that that they're numerical in nature. And you can see that once it saw one decimal, it assumed everything is a decimal. And this is something else to point out when you're structuring some kind of data or you're organizing it. You want to make sure the whole column can be of one data type. And so you see in dim2, you don't see any highlighted value, any colorful values, which indicates that everything is text. You can also kind of see that it didn't know what to do, so it just assumed it saw one text value, something that couldn't be categorized as an int or float or anything like that. Said, okay, this must be all string. And then here we have just more ints, just similar classes. And we can see that if we print out our data types, so we are able to read it in the console. Let's actually clear this out. And you can see that. So class here is int. Dim1 is a float. Dim2 is an object, which is another way of just saying it's string. That's how Pandas deals with strings. It calls them objects. And dim3 is int64. So again, you can kind of see how technology also calls things a little bit differently. And even Excel will call things a little bit different. It doesn't call things float, it calls things decimal. But at the core of it, it's all the same thing. Again, I don't know why in the world of data, I think in the world of technology in general, the same thing likes to be called different things by different people. I don't know. It's a weird thing. I don't get it. I wish everyone could just call everything the same thing, so it's not so confusing sometimes where you're like, isn't this the same thing as the other thing? But that is your introduction to data types in a programming sense, in a general programming sense. So if you're have any aspirations to program, data types important. If you have any aspirations to work with data in general, you should know data types, because it goes hand in hand with levels of measurement. Because as we saw here, we wouldn't want our inferred to stay, our class column to stay as an int. It should be an object. It should be text. And we should also, and the other one, it was a dim2, I believe. Let's actually just look at it real quick. As dim2 here, we probably would want to get rid of the hello. The hello seems like something wrong here, right? And then we can decide if we want dim1, dim2, and 3 to all be floats, which would probably be the case. because we have at least one decimal. Or maybe we want to round it and make everything to the whole number. Who knows? But data types, again, are important. They are the how we kind of deal with levels of measurement, how we get 1 to not equal 1 when appropriate. And in part 2, we are going to be looking at this same thing in Excel. And you're going to really, I think you'll be surprised at the sheer amount of overlap these two technologies have that you might not consider at first, and how much, again, they have in common. So that's it for today's video. Stay data driven. Join me next time, and I hope you have a great rest of your day. Bye.